Jai Hind, ladies and gentlemen, welcome back for the sixth session. We had some very interesting, very fruitful, very constructive sessions, and I'm sure this is even as fruitful, if not better. The sixth session on tracking, controlling, and reporting of common operational picture, and this was discussed or mentioned as an imperative yesterday by no less than the Vice Chair staff, as also the DG operations. And situational awareness, of course, is something which is key to our air and missile defense. So that is where we come to this very interesting and very important sixth session. The session is for 1 hour, and we have no less a tall figure than Air Marshal Ramesh as chairing the session. Thank you very much, sir, for sparing your time and for support to Center for Joint Defense Studies. We read what you write, and it's always a pleasure just listening to you and to studying what you write. Thank you very much for joining. I will not even do the mistake of introducing you to this panel and to the participants. He's well known. We also have Mr. Noam Shultz, who will be speaking to the multi-graded integrated C4I systems. Thank you very much for joining us. You, of course, belong to the Rafael Advanced Systems. Thank you. Then we have Air Commander Trilok Chand, a very prominent fellow for the Center for Joint Warfare Studies. He is a real asset, and he'll be speaking to us on the identification of friend and foe and the common operational picture. Then out of a very interesting topic, actually, that we covered by Air Commander Satbir Singh, and he'll be speaking to us on the Puldia arms drop. And last but not the least, we have the radar expert of the country, Mr. Vasudev R. He'll be speaking scientific F, the LRD, and he'll be speaking to us on the latest developments in air defense radars. Without much ado, all yours, Air Marshal. Thank you.
Let me first begin by thanking Director CENJOWS, General Vinod Bhatia, to come for this webinar and chair the last session, which is on control, reporting, and the common operational picture, and other nuances of battle management. I think, like he said, it's a very important session, and I hope we have a good one. But before I go on to the theme of this session as such, I want to make a few points, because I find that over the last 2 days, the entire webinar has a lot of a land forces flavor, a lot of a Army air defense orientation flavor, and I want to give it a little bit of an air power rub because that's where it really belongs. Let me start by a gospel that most of the armed forces have come to accept, and that is that no country has won a war in the face of enemy air superiority, and no major offensive or defensive operation can succeed against an enemy who has the control of air. So attaining air superiority is a prelude to military victory, and this is very important. Why I say this in the beginning is because, like the CDS reiterated in the start of the session, that there is a big reform for the armed forces coming. And as part of that reform, the first step is the Joint Air Defense Command. And thereafter, the Joint Theater Commands would follow. So what we have to keep in mind while restructuring our forces is that this gospel is not lost track of. This gospel has to be adhered to, because future wars will be multi-domain wars. And we have to make sure, while recombining, while integrating, that the domain-specific operational art of each domain must combine to enhance the operational capability. But I see that in defining an air defense command, we will diminish the operational capability of the Air Force. And that may not go very well in our favor, because whoever controls the air generally controls the surface. Now, let me elaborate on this before I come to the theme of this session. Now, while integrating all the air defense assets of the country is a great idea, but forming a command is not such a good idea. Now, I want to start by stating what Air Marshal Anil Chopra has recently said in his article, And I don't know whether he said it when he was chairing a session because I couldn't hear him. Nevertheless, he goes on to say that Aerospace Defense Command, created by the United States in 1968, was deactivated in 1980 because of its unviability. Likewise, China does not have an air defense command. Russian Air Force and the Russian Aerospace Defense Forces merged with each other in 2015, just 4-5 years ago. And Russia now, of course, has an air defense and anti-ballistic missile defense forces command. And I was reading about this on a link which goes by the name russianmilitaryanalysis.wordpress.com. And it went on to say that the Russian Air and Missile Defense Command is a wanton confusion, implying outrageous confusion between the aerospace forces, fielded systems, ground forces fielded systems, and the Russian Air Force. Now, this aspect is seldom spoken about while painting a picture of its efficacy. Let's dwell on this further. Now, this particular Russian command has 800 aircraft assigned to it, out of the 4,000 or so that the entire Russian Air Force has. So that means 1/5 have been assigned to the Air Defense Command. Now let's translate the same model. I don't know what model we're going to follow, but let's translate the same model onto India. If we were to assign 1/5 of our squadrons to the Air Defense Command, out of 30, that would be 6. We would be left with 24 to be divided in the 3 theater commands. Even if we didn't give anything to the Peninsular Command, there will be 12 going to the theater towards Pakistan and 12 for the theater towards China. Look at the asymmetry that we will build in. 12 against the 22 of Pakistan and 12 against the 20 or 25 that China fields. I need not elaborate further that in the case of such asymmetry, attaining control of the air or attaining air superiority will be well nigh impossible. And we would have already lost the war, like I said, as part of our gospel. So the Air Defense Command, to my mind, is an unviable proposition on 3 counts. And I will speak about them. First is the lack of resources. I've already spoken about the lack of resources before arriving to this point. The second is the operational unviability. And the third is the doctrinal unviability. Let's go to the operational unviability now. I hope you would have understood what I meant by lack of resources. Now come to the operational unviability. Now, in the army or in the land forces concept, the air defense is a support function. They support to attain air defense of the tactical battle area. But in the Air Force's operational concept, the air defense is part of the counter-air campaign. A counter-air campaign is launched to attain air superiority, the one that I've been harping on, the one that is essential to win the ground war, essential for the army and the navy. Now, this counter-air campaign has 2 sections. An offensive counter-air, where we go into the enemy territory and hit them, and defensive counter-air, where we hit the enemy if they are intruding into our territory. So both are to be run simultaneously by the same commander, under the same command and control. The offensive and defensive operations are intertwined and cannot be separated. So this is very important to understand, that by establishing an air defense command, we are splitting the primary function of the Air Force, that is to attain air superiority. That means we are separating the air defense, the defensive and the offensive operations. Now that's not a good idea. It is to be understood that these assets cannot be divided into defensive assets or offensive assets.
Yes.
Most of the other assets like AWACS, FRA, etc., again contribute towards defensive operations and offensive operations, and these cannot be separated. Dividing them would be like, in army terms, placing the pivot corps and the strike corps under different GOCs, under different army commanders. Now that would be totally unthinkable. Likewise, dividing the air into offensive and defensive pockets would be a death blow to air power or to the air war. Now I come to the doctrinal unviability. Now, doctrinally, establishing a pan-India air defense command cutting across all operational theaters and boundaries represents an army view of air defense much like a support function. That means supporting the offensive elements, say like training or logistics. But air power is the offensive element of our armed forces. It cannot be tied down in a defensive mode. Our forces cannot sit back in a defensive bubble and get eaten by the enemy's aerospace attacks. So this is very important. Now, I have been emphasizing on achieving air superiority. Now, this emphasis sometimes is not liked by the ground commander because they tend to equate proximity of the air with security. They want the air to come the moment they call for it. Now, this thing is understandable, this desire is understandable, but a bit misguided because it would be unwise to tether air power to a static defensive role. And that is the doctrinal unviability that I want to say. Moreover, like I covered earlier, a future war will be a multi-domain war, and in which each domain will have to dominate. If we split the air in penny pockets, the air will not be able to dominate. For we are already at very low numbers. We are at 30 squadron. And this situation will remain at least till 2035. And I see the government approved 42 coming only at 2040 or beyond. So for the next 20 years, this is going to be our situation. Even once we have 42 squadrons, the situation will not change very, very much if we divide them into penny pockets. This parceling out of air power is what any air power practitioner will deny. He cannot fathom even a thought of this kind. And history has shown that diluting air power will always lead to the loss of operational potential, which will cost us the war. And finally, before I come to the theme of the seminar, is we already have a well-established operational air defense system going in the Indian Air Force. It is data linked. It is well integrated. All the other assets of the Army and the Navy are welcome to join on it. And that's what we will discuss now. But the creation of an air defense command is not a good idea. And there is a famous saying, if it ain't broke, don't fix it. So the air defense structure is going absolutely well. I don't see any need to fixing it and to creating another plethora of difficulties and problems. So now I move on to the session theme as such, and I'll speak a little bit about it, and then ask my co-panelists to come on. Now, control reporting and obtaining an air situational picture or the real-time situational picture is the most important aspect of battle management. To identify an intruder, to track, to see the progress, and to bring to bear the most appropriate weapon is the most important thing. That is before this intruder can do any damage. Nowadays, in today's times, in today's technology, it calls for a real-time connect between all the clients, between all the players. The sensors to give us the combined picture of the situation, weapons to be ready to be launched as soon as the command comes. And that calls for an operational data. It calls for networking of
the audio on the
computer to come on the operational data. So a network, so we have to make a network for ourselves. There is a network already going for the Indian Air Force called the IACCS. It needs to add on the operational data links for exchange of data in the air. It is presently only floating on the Air Force net and more ground tethered, and it needs to go on the air. Likewise, the Trigun and of the Army and the Navy need to come on board. Trigun and Akash Tir need to come on board. When I was in Israel as the defense attaché, I found that the three services had their own operational data links, which were combined now with one overarching one, so that only the requisite information flows from one to the other. So that once we create the data link, we ensure that only the requisite amount of data and the right amount of data and the right picture goes to the client, depending on his requirement. So this kind of an architecture, I feel we will have to build indigenously, so that we have all the protocols, we have all the know-how, how to change it, how to create the logic, so that the correct picture goes to the correct client, and we in turn get more effective. Now, this is what my first speaker is going to speak on, to speak about multi-integrated C4I air defense system. He's from Israel, from Rafael Air Defense Systems. So kindly tell us how easy or difficult it is to indigenously produce an operational data link and to make the logic in that data link so that all the clients are satisfied. Over to you.
Okay. Thank you very much. Good morning, everybody. Thank you for having me here. And anyway, I would like to give a very short brief over principles of building air situational picture, COP, Common Operational Picture. And later on, I would like to have a few minutes to present some of our very advanced laser weapon, which is not regards to this session, but it's for the advanced air defense technology, which was on Saturday, and I'm sorry I could not speak on Saturday. Nevertheless, please let me start with my presentation about air situational picture, and then we'll go forward from this. I would like now to share my presentation with you. So what I would like to emphasize here is our multi-integrated command and control air defense, which are talking about COP or ASP solutions. I will start with an illustration, a very basic one, in order to understand what we are talking about. We're talking about the full of threats, friendly aircraft, and multi-sensors, which need to cover the relevant skies of ours. All of these should be actually integrated in one real-time, updated common picture, which can be done with a relevant tracker, which is a very, basically it's a very algorithm, a very sophisticated algorithm can do it and build up our common operation picture or air situational picture as well. So this is one example of it, and I will get into some key points when we are building this capability, what is it all about. First of all, when we built up our ASP, it's actually to provide our capability of SA, situational awareness improvement. That will help us at the command and control process, first of all, to avoid particide, and the other side is to do air defense assets implementation. So how we can do that? We built our picture to build our SA in order to have what we called TEWA, threat evaluation and weapon allocation. So threat evaluation based on very unique artificial intelligence and machine learning. Let me show you a short example of this. Over here we see unrecognized tracks with NATO symbols in this picture. And now, actually, the tracker automatically, by machine learning, can define, first of all, what is the classification of those targets before identification, and we'll get it later on. So first of all, artificial intelligence can help us to identify if it's a fighter, RPV, any chopper, or whatever. After we do the threat evaluation, we get to the weapon allocation. In this video clip, we will see a simulation of threat over here. And over here, we have our capability, our assets. In this kind, it's a 3 Spider batteries with a fighter's base over here. We actually, with a special algorithm, can plan which is the best solution in a matter of time and space to meet this target. When we do that, we can actually choose one of the targets and then to allocate the target, to pick up the solution, the weapon system, and then actually to allocate this target to the relevant battery, SAM, or a fighter, which will be the best solution in a matter of time and space. Of course, all those algorithms, it's built in the system. So when I get to the multi-integrated C4I, which I like to emphasize here, I would like to take it to as a C4 layer between air defense assets and the air operational center. Okay? The idea is actually to integrate some of SAM capabilities like Spider and others with multi-sensors integrated to command and control in between the air operational center and the batteries themselves. That can be done by putting operator workstation in the AOC connected to the SAM sites, or to build up few workstations which can work simultaneously and parallel to the air operational center. We also can build it up level to national level, but it's not the issue right now. This is a short video clip can show how it can be built as Spider in this case. In this one, you can see that we built up the picture from the assets themselves and then integrate it to upper echelon. That can be, of course, mobile and also can be transferred by air, which you can see in a minute. That is how it can be built. Okay. So, for example, we did it for the UK, but let's not get into this. For the other topic that I would like to mention is our capabilities with laser. Last time I was attended IMR, and I was attended physically, and it was much better than to do it like that, but we'll wait until COVID-19 will be passed over. Anyway, I showed you the drone dome counter UAS. Today I would like to emphasize the hard kill capability, which is the laser. I will not go to too many details, but people can understand what are the advantages of laser as a high energy weapon system. It's quite cost effective, highly accurate, very highly accurate, quiet, and cost per kill is like nothing. Of course, we have challenges with it. We need line of sight, limited by atmosphere, of course. Those are some pictures of our system. And the idea is to shoot down any drones or other subjects up to 2 kilometers and down with a detecting it, queuing it, targeting it, and shooting down. A lot of questions I have with the safety concept. Without getting into too many details about it, we are dealing with S-codes, is keep out zone, which can be static and dynamic, and then to do it very safely. And a short video clip from the last one, which is going to show you the capabilities of shooting down by laser maneuvering drones. It's take only 1.5 minutes. We can burn the camera of the drone so precise we can do it. Here, it's on maneuvering drone, maneuvering, not just standing in the air. And the key point is the beam director, which we developed. Again, maneuvering target, shooting down by laser. Here we can see a group of drones which can be shot one by one. Demonstration last December here in Israel, just before the COVID-19. And this actually concludes my presentation on the chatter here somewhere. Thank you very much.
Thank you, Noam, for giving us an overview on the capabilities of Rafael Defense Systems and what all work you have been doing, very advanced work, which Israel is, of course, famous for. But what I would like to add and share with the audience is that in our unique case, establishing the operational data links is going to be quite difficult. That is because we have equipment of various vintage. We have equipment of various OEMs, which have different protocols, which will require different communication methodologies. And producing the ODL itself, firstly producing the software-defined radio and the ODL and the RF generators and other equipment to put the data on it and then distribute that data calls for a ODL gateways, which are the most complex to build and which have no template. Now, ODL gateways are complex to design because they translate operational concepts across the various ODLs that we will have to make. In our case, different ODLs will be within the Air Force and then translating to the other services, which may also not have one operational data link. There is nothing like a universal data link in this world. So each operational data link serves a specific purpose, and then we have to combine them. And that is where the expertise on linking the operational gateways comes in. Anyway, but inherent to the network architecture is this aspect of friend and foe. The people or the entities who are on the network are friendly, and those who are not on the network are not friendly. And that is also the topic of our next speaker, which is Air Commodore Trilok Singh. He'll speak to us on identifying friend and foe. I hope you dwell on how it will be done on the network and, of course, obtaining a common operational picture. And over to you.
Good afternoon, ladies and gentlemen. It is just past noon now. I have been asked to speak on identification of friend and foe and also on common operational picture. I will be covering both of them. I have prepared a short presentation. And since I noticed there was a lot of disturbance in the audio system yesterday, so I would be presenting my text also on the screen as I speak. Therefore, I switch over to presentation. Okay, good afternoon, ladies and gentlemen. I will be speaking on identification of friend and foe, and later also cover the common operational picture. In air defense, we always start with the detection, move on to identification of friend and foe, then of course tracking, destruction, and finally we want everything to be seen in some operational room. Therefore, we have to have a common operational picture about which much has been talked about by the previous speaker. But I would be speaking in a much more broader sense, not only about the common operational picture of the Air Force assets, but of Army, Air Force, and Navy in general, and of course, how it can be shared globally with other forces, knowing that we are likely to be part of multinational forces as well. Detection, much has been talked about. There has to be a series of radars along the borders, coastline, inline. They have to be network and information fused. Secure media and secure hardware and software have to be used. But what identification? We know that identification of friend and foe so far was being done through interrogator transponder system, in which the word over IFF Mark 12 system is being used. Of course, IFF 10 continues to be used in certain areas. IFF Mark 12 has got 4 modes. The second system, which is widely in use now, especially in NATO, as I will elaborate a little later, make use of a technology, automatic dependent surveillance broadcast, ADSB system, and a IFF system known as IFF Mark 12A has come into being. It's a satellite based and it makes use of one mode. Therefore, it has got 5 modes. Let me now recall a little bit about the utility of the IFF. We know that IFF is a tool within the broader military action of combat identification, the characterization of objects detected in the field of combat sufficiently accurately to support operational decisions. The broadest characterization is that of friend, enemy, and neutral or unknown. Third one is also to be taken into account, which the equipment may not be able to do, but the procedures will have to account for it. Then the combat identification reduces friendly fire incidents and contributes to overall tactical decision making. We are very well aware of this problem of friendly fire incident, which have taken place world over, including in our own subcontinent. We are all familiar. Therefore, the system enables military and civilian air traffic control interrogation system to identify aircraft, vehicles, or forces as friendly and to determine their bearing and range from the interrogator. I'm now talking about beyond the Air Force, where the vehicles, ships, and other things will also start coming into picture. The system is in use since World War II. The 13th iteration is now in use. As I just said, IFF Mark 12 is used in most part of the world, but IFF Mark 12A, especially NATO has started using. This is how the typical equipment looks like: the control unit and the transponder and the antenna and the location on various parts of the aircraft. Technically, how it is fitted into different parts of the aircraft. This is a typical equipment, the one which is made by Thales. But there are very many countries, very many companies which are making, including IFF Mark 12A. There's a typical block diagram. Most of us are familiar with it. For the transponder and interrogator have transmitter and a receiver inbuilt, coding, decoding, antenna, and everything else. They make use of different modes. Most of you are familiar with the different modes, but I'll just summarize both military as well as civilian modes in use. IFF Mark 10 and IFF Mark 12 systems, as I said, are in use in different parts of the world. Traditionally, IFF Mark has been employing mode 3, where mode 1 is used for identification of the aircraft mission, mode 2 is used for identification of the aircraft per se, and mode 3/A is used by military as well as commercial establishment to identify the aircraft and also to notice its height by using mode C. These are the typical pulses which most of us are familiar, are made use of in mode 1, 2, 3, and 4. Mode 5 waveforms are not shown. They're much more complex. The system is much more complex. I'll be elaborating it in a little bit more detail. IFF Mark 12 employs mode 1 to 4 and is widely used globally, as I said. This works on the same frequencies as Mark 10 and supports all of its military and civilian modes. The main reason for the creation of Mark 12 was for the addition of the military mode 4, which itself has got a history. Mode 4 started with an interrogation similar to mode 3, but then followed that with an encoded pulse chain similar to one used in mode 3/A, but the aim was to ensure that unexpected interrogator do not get a response from the transponder. This largely eliminates the ability of the adversary to trigger the transponder. We are aware that during the 1980s, a new civilian mode known as mode S was added to that allowed increased amount of data to be encoded in the returned signal. This was used to encode the location of the aircraft from the navigation system itself. This is a basis or a basic part of the traffic collision avoidance or TCS system that allows commercial aircraft to know the location of the aircraft in the area and avoid them without the need of ground operators. The basic concepts from mode S, which I said were developed during 80s for civilian use, but then militarized as mode 5, which is simply a cryptographically encoded version of the mode S data. I will elaborate it a little later. But therefore, we now talk about IFF Mark 12A system, which at the moment is in use mainly by the NATO forces because of several reasons. The system employs additional mode 5. Mode 5 employs a cryptographically secured version of mode S and ADS-B GPS position, and mode 5 is the newly developed encrypted data link between interrogators and transponders, and the data link has been talked about. I will talk a little in detail in subsequent slides. There are civilian or commercial modes of the IFF, mode A, B, C, D, and S, and they very much correspond to the military mode, but are basically used by the commercial aircraft. Mode A and C responses are used to help air traffic controllers identify a particular aircraft's position and attitude on a radar screen in order to maintain separation. Mode S transponders are compatible with mode A and C's country surveillance radar system, so there's no conflict of interest if you use different kind of equipment. Having just refresh your memories about the basic type of IFF systems which are used, let me move on to the new technology which is being used in mode 5, automatic dependent surveillance broadcast or ADS-B system, widely being used by commercial aircraft. In this technology, an aircraft determines the position by a satellite navigation and periodically broadcasted, enabling it to be tracked. Most of you have seen, even on your PCs, when you want to see the flight position of your near and dear one going from India to other countries or even within our country, this system is that time in use. The information can be received directly by air traffic control ground station as a replacement for secondary surveillance radar, as no interrogation signal is needed from the ground, a great relief to the ground station people. It can also be received by other aircraft to provide situational awareness and also ensure self-separation I mentioned in TCAS system. ADS-B is aromatic. It requires no pilot or external input. It is dependent as it depends on data from the aircraft's navigation system, which in turn depends upon satellites also. The Airport Authority of India has commissioned ADS-B ground station at almost all important airports in India to ensure a smooth commercial navigation of aircraft. Let's now talk a little about the new system, which I would wish and recommend that our defense forces also acquire and use, because it is something futuristic. It is something which overcomes more the problems which the previous legacy systems, IFM Mark 10, Mark 12, have been having. This system makes use of ADS-B system also. Range restrictions are overcome to a great extent. Security concerns are addressed through encryption. And Mode 5 encrypted data link is essentially needed for secure identification of our aircraft of our defense forces as well. Therefore, I would wish that we go for this system. This is as far as the IFF is concerned. I will now move over to common operational picture, which my predecessor has talked about with reference to efforts requirement. I'll broaden it to inter-service and then international scenario, and then also talk about the tactical data link, which the chairman himself mentioned, where we are and where we can go and how we are going there. Common operational picture, as has been stated before, is needed to facilitate collaborative planning and combine execution and assist all echelons to achieve situational awareness. A very important term. Inputs from all available sensors are integrated and optimized in the system. Identification of friend and foe is established by making use of various methods in addition to technological, which I have mentioned. There are procedural things which all Air Force operators are quite familiar. And thereafter, secure communication is provided. My predecessors showed some of the screens of Air Force, common operational picture. I'm showing few where Army, Air Force, Navy, everything is integrated. Of course, for then one pages, it can be switched for getting different sets of information. But this is how something will look like. Or more importantly, it might even look something like this, which the NATO people, NATO forces are already using. Or maybe it'll look something like this. Or it maybe it'll look something totally different. But let me now cover slightly in greater detail about the common operational picture. The common operational picture capability can be defined as the ability to display on a single screen integrated views that recognize maritime, air, and ground pictures, enriched by other tactical data such as theater plans, assets, intelligence, and logistic information so well required by planning your actions in operational room. The purpose of the COP capability is to provide military forces a comprehensive view of the battle space, thereby enhancing situational awareness and the decision-making process across the military command and control spectrum. The availability of a COP capability throughout the command structure is a high priority operational requirement in NATO because there it's not one country which is operating, but it's a plethora of countries using different systems which are to be integrated, as the chairman said, and the real picture of interlinking or synergizing all the capabilities of various TDLs arises. A COP capability for NATO is being procured and implemented. It's a work in progress in an incremental way within the NATO Automatic Information System functional service program under the coordination of the NATO Consultative and Control Agency, Integrated Program Team 5E, or known as IPT 5. Let's move further. The NATO Initial COP Capability Project will provide an initial COP capability to NATO by using existing operational communications infrastructure and NATO systems. How? NATO-wide integrated command and control software for air operation, ICC, the Maritime Command and Control Information System, MCCIS, and Joint Operations and Intelligence Information System, JOIIS, which will provide respectively the recognized air, maritime, and ground pictures in one place. Tactical data link is the means to disseminate processed information from radars, EW, IFF, sonars, and information related to various combat functions between the fighting units on a battlefield. Despite the existing communication compatibility and security agreement framework for the interchange of encrypted communication between India and US, effective joint operation using ships, submarines, and aircraft shall be possible only when interoperability is achieved at the tactical level through TDL of each force. As I said, first we have to achieve it with Army, Air Force, and Navy within our own country, and the work is under progress, and I'm going to show it in the forthcoming slide. And then in case we want to join the international forces, for which we've already signed the COMCASA, but even though you may have common equipment, you may have procedures, but unless you have TDL, which is also facilitating, you cannot move further. The COMCASA allows greater access to critical communication networks for interoperability, and this agreement will support installation and exploitation of high-end security gadgets on the US-supplied defense equipment, which we all know, and to some extent we are using also. The TDL exchanges digital information on a real-time basis or a common network. Within this tactical data updated continuously and automatically by each of the net units or node. The TDLs have several components like the radio set, RF generator or waveforms, and blends the information being moved across the combat echelons in a network-centric environment. And the radio set has got a critical role. Link 16 and Link 11 system have been in use mainly for TDLs in US and by the NATO allies for decades. Link 16 equipment is located on ground units, sea-based assets, and airborne platforms, and is continuously being enhanced for effectively producing COP for efficient and effective use of fighting assets. India too has its own equivalent indigenous data link and is being utilized on board warships for tactical information exchange between various assets on sea. Each of the TDL uses a different standard communication protocol, and MIL standard 6011C sets the message standard for data link interoperability. This is to what the chairman in his opening remark was talking about. Therefore, the combined operations between the US and Indian forces may be possible after linking up of the two TDLs, Link 16 and India's indigenous link equipment, which in itself is a big challenge unless an innovative methodology like limited message retransmission amongst these two TDLs evolved, keeping in mind real-time data. Now, the common operational picture, recently we have seen a step in this direction has been taken by the Indian government. The Defense Acquisition Council approved induction of software-defined radios technology for tactical communication needs of our armed forces. This SDR, to my knowledge, has been indigenously designed, developed through joint efforts of the Weapons and Electronic System Engineering Establishment, WEC, and Defense PSU, BEL, and a similar effort is in progress by the Indian Air Force and by the Indian Army to accomplish their own SDR to meet on unique requirements, which to some extent will be different from the naval requirement. Overall, the incorporation of SDR technology within India's indigenous data link equipment shall be the key factor for achieving interoperability first within the services and then with US Link 16 and in turn achieving the desired standards for combined operation between US and Indian forces in international environment. Thank you, gentlemen. I finished.
Thank you very much, Commodore Trilok Chand, for a detailed discourse on the IFF and how it does the identification of friend and foe. My problem with the IFF is, what if the IFF is unserviceable? What if it's not switched on by erroneously? We'll have a problem. So networks by themselves will provide us a very infallible IFF system. You dwelled also a lot on the common operational picture and enhanced our understanding. Now let me tell you the practical aspects of the ODL. In the year 2005 in Israel, I received an Indian delegation which came to evaluate the tactical data links in Israel. It's 15 years, we have not been able to develop one yet. And hopefully we should soon. We are, I believe, in collaboration with some company in Israel, and we should be able to, which is what we want. The second aspect is about integrating it within the service and between services. Now, the United States Air Force has been getting their networking going since the mid of 90s. In the year 2020, they are still not sure whether they have it right. Because the ODL gateways and protocols are very, very difficult to design. So while it is okay to say, yes, we should have one, but what I would say, let's get one first, see if it works. Otherwise, the entire AD structure, which is dependent on this control and reporting, will collapse in case we don't have the operational data link and we are not on the same grid. And like the Russian system, we will also have outrageous confusion. So that's what I want to add to that. So it's very important that we go step by step. And let me also dwell further to tell you that the Pakistan Air Force has produced an indigenous data links. Sometimes they call it the Link 17, sometimes they call it the National Data Link. The Link 17, let's say, links with the Link 16 via their AWACS. Likewise, when we make data links, because they are line of sight, we will need to link them via our AWACS or satellites. Now, in case we have to link them via satellites, then imagine if it's a pan-India AD organization, how many AWACS we will need. So that kind of a detail needs to go on. And by the time we get the satellite going and every aspect is covered and that is analyzed, an AD structure without having these aspects covered, I guess should not be configured. Let me talk a bit about China. China has created theaters, but they have not assigned forces within these theaters. They will assign forces to each theater, operational forces, depending on the threat, to match the threat or to overwhelm the threat. And these forces, because they will come in force based on the threat, they will all be data linked. And that is why they call their operational concept should be successful in an informationized war. Anyway, so that much said, thanks a lot for the lovely discourse. Networking is really the key to future operations and to combining domains, like I said. And since we have about 10, 12 minutes, I will just say a few words longer than what I had intended so that we finish on time at 1 o'clock. The first point that I want to make is that networking inherently implies integration, irrespective of the structures that a country may have. And this needs to be pondered about. That is because there will be, after we have networked, a combination of all the sensors, data flowing, with the real-time picture reaching the decision maker and also reaching the fighter, whether he's on the ground and he in the air. Now the decision makers, since they're from all domains, since they are seeing the same picture, will have to quickly confer with each other, which means integration, and then decide on which weapon system will take on the target in all aspects of war. So actually networking is the key to integration and not dividing ourselves into various structures. Of course, if that's done for another implication, it's all right. But whatever structures we decide for ourselves must make sure that the air domain is uncompromised. And we must think them through together, a debate over them, war game them for a finite time. Let me just share with you that the Goldwater-Nichols Act, which we often quote and tend to copy and tend to assume that it has brought the US Armed Forces integrated together, etc., was discussed for 4 years and 241 days in the Congress, in the US Parliament. And our structures, which are going to change the entire complexion and have direct implication on the security of this country, I wonder how much longer discussion it has had, but it should have. And we should work towards that. The next point that I want to make is, why do I speak so much on do not dilute the air domain? That is because I've already said whoever controls the air will generally control the surface. And no less than Field Marshal Montgomery said this after the Second World War. And to quote, he said, if we lose the air war, we lose the war, and we lose it quickly. This is because native domain. By whatever mechanism we fight, it is a cognitive outcome. Throughout history, there are very few battles which have been won by completely destroying every fighting entity or every soldier of the other country. The enemy gets defeated by the accumulated stress of war or by the perception of a situation that leads to fear, fight or surrender. That means the outcome is not going to be in his favor on that cognition. But if the air power is diluted, then our enemies, rather than being dissuaded or deterred, will get emboldened because they know that air power will have the key to a future war. Two domains will come in the fore in the future: the aerospace domain and the cyber domain. The aerospace domain is already here. The cyber will probably take some time, and we'll see how it shapes up. So in dividing air power, we are only losing potential. The next point. We have a lack of resources, a shortage of resources. So for the next 20-25 years, till we have the requisite numbers to fight a two-front war, how are we going to manage? We are going to manage this only by multiplexing whatever we have. We have to multiplex it across theaters, across the entire battle space, across the offense, defense operations, and then only achieve to deter the enemy. Another point that comes to my mind is that future war will also be a hybrid war. A lot is spoken about it. A lot is written about it. Now, the degree of hybridity will vary as we go along. So we have to see that, are we creating theaters to fight a hybrid war? Can we do that? Because a hybrid war will have to be very centrally controlled. And a lot of other speakers and other writers, and I want to quote three of them. One from the army, that is Lieutenant General Prakash Menon from the Takshashila Institution, has written that the air defense command is not a viable idea. Likewise, Admiral Sundaram of the Indian Navy has spoken about the air defense combined. And also Group Captain Ashish from the IDSA, who's written recently about a single theater, which is the most viable way to go because it will give us the flexibility to configure our forces depending on the threat, much like how China is doing, so that we can contain the threat wherever it emerges. And if it is on both sides, then we can multiplex the air assets, multiplex to win the air war, to get the air superiority. Finally, airspace is the domain of the future, like I said, and whoever controls the aerospace domain will control not only the war, but also the planet. So I want each of us to be amply clear, and it must be clear that IF must be configured in such a way, whether it is integrated in whatever means you feel it is appropriate, it must be configured to win the air war, for only then will the army and win their part or the surface war. Thank you very much. And I wish to thank CENJOWS once again for putting together a very comprehensive webinar, which was delightful to be a member, a part of it. I hope it conveys the right messages to the policymakers so that in the end, we have structures that will also integrate us, and yet each domain will flourish to dominate the enemy. Thank you.
Thank you so very much, Marshal, Ramesh. Thank you very much, all the speakers. It's been absolutely a delightful, educative last an hour and a half. Thank you so very much. Very interesting. I remember what the chair said is very interesting. You know, the operational unviability and the doctrinal unviability of air defense command. I totally and fully agree with you. There's no denying that fact. There's the pro rata distribution of a resource which is very scarce. That's not the right way forward. We're not denying that fact. I think we'll get it very wrong if we think that if we actually implement it. I'm in full agreement with you. But like the chief of the defense staff said yesterday, they're looking at an aerospace theater, which is all encompassing, which has all the resources with it, which has the authority and the accountability with it. And that is how they are looking at aerospace. They are totally integrated, synergized, harmonized, and whatever we wanted. It is under one commander, one theater commander. So that is what it is there. I think he gave a time frame of December, if I'm not mistaken, all of it out here. So the key issue is getting the aerospace theater right. There's a multi-domain warfare. The days of linear wars are over. Even nowadays, with what is going on in the LAC, I find more and more everyone analyzing and saying how we are stronger than China. Definitely we are strong, but how we are stronger than China in an air-to-air battle, in a navy-to-navy battle, in an army-to-army battle, how our army is battle-hardened, it is very superior in high-altitude warfare, how our Air Force got the T3 advantage, that is training technology and terrain advantages, how in the Indian Ocean region our Navy is much stronger. Armies, navies and Air Forces do not fight wars. The wars are fought by nations and by the Indian armed forces on behalf of the nations. So it is not, the Air Force will fight the Air Force, the Army will fight the Army, and the Navy will fight the Navy. I think we'll go very wrong in a thought, and it's a daily thought which is occurring. The way ahead, and whether we like it or not, the decision has already been taken, and this was said so in, I think, 2015, December, by the Prime Minister himself, that you have to go join, you have to integrate, and to that, I think the issue is now, the challenge right now is to get the aerospace theater right, to ensure that we are present relevant and we are future ready. So I will leave it at that. There's a different discussion altogether. There will be no division. Division is the wrong thing to do. Dividing sources is totally incorrect, and I don't think it's going to happen. It's integration rather than division, what we should be looking at. And offense, of course, the West Front defense, offensive and defensive operations have to go together. The challenge lies in getting a favorable air situation, and situational awareness as a subject for this discussion is exceedingly important. And how to go about it has been detailed out here, so I will not go into that. I just leave it out here, and we have the next session starting in a couple of minutes' time. We are on time, and time is very important, especially